Good evening, children. Welcome to geometry class. Yesterday we have studied 4.1 exercise. In that, the basic ideas of geometry, the points, lines, rays and line segments with parallel lines, straight lines, all these we have studied. Today let us study the curves. So these are all the curves. See, all these are curves. This is not curve. Why? This is a straight line. In only one direction it is said to be straight line. But what about these? These are nothing but the curves. So what is a curve? So a curve can be drawn of these drawings without lifting the pencil from the paper and without use of ruler. We are not using any ruler or scale here. Simply we can draw like this is a curve. Curve in everyday usage means not straight. It's not a straight curve. But in mathematics, a curve can be straight like the sea. It can be straight, but it may be simple curve. Simply, see, you can draw. Okay, these are the curves. So what is the difference between these? Any difference is there? Yes. There are open curves and closed curves. See, these are all open because there is gap between when they start and complete, there is a gap between them. They are open. Whereas here, it's a closed curve. When we start drawing and complete it, it becomes a closed figure. It's a closed curve. Okay? Closed curve. There is no gap between them. So like this, the curves are open. This is an open curve. Okay? And these are closed curves. Now let us see position in a figure. What is a position in a figure? A court line in a tennis court divides it into three parts. You have seen the tennis court, children. There is inside the line. Three parts are there: inside the line, on the line and outside the line. Okay, you cannot enter inside the line without crossing the line. And a compound wall separates your house from the road. You talk about inside the compound, on the boundary of the compound and outside the compound. Okay. So in a closed curve, thus there are three parts. You can see three parts in a closed figure. This is boundary of the closed figure. On the line, inside the line, outside the line. So like this there are three parts. Interior is inside the curve, interior, and on the line is boundary, and exterior is outside it, is exterior. Okay. Now let's see the shapes. The triangles you have studied from second standard in the lower classes. Now we'll study more than those. See, this is a triangle. But whereas it has how many sides, children? A triangle has only three sides. But what about these? It has five sides. It has many sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 4 sides. Here also many sides you can see. So what are those? These are all polygons. Poly means many. The many-sided figures that are closed are said to be polygons. It means a polygon is a simple closed figure made up of entirely of line segments. These are line segments. See, all these 5 line segments together form a 5-sided polygon. So it is named as pentagon. Penta means 5. So let us study polygons in this unit. So these polygons have sides, vertices, diagonals. Means these are the properties of polygons. A polygon has sides, vertices and diagonals. Let us see one by one. Here is the figure, 5-sided polygon. How many sides it has? 1 AB, 2 BC, 3 DC and 4 DE. Fifth one E, A or AE. So all these 5-sided segments form the pentagon. So what are vertices? Vertex. A is the vertex formed by 2 sides. When 2 sides intersect at a point, they form a vertex. Vertex, singular, vertices, plural. So how many vertices are there? Vertex A, vertex B, vertex C, vertex D, vertex E. So how many vertices? 5. And diagonals. When you try to join the adjacent sides by their vertices, they are said to be diagonal. For example, from A to C, this is the adjacent vertex. So these 2 adjacent sides are joined by this line. So this line is said to be diagonal. And these 2 adjacent lines, adjacent means neighboring, side by side lines. Line segments are joined by a line by EB. The sides EA and AB have the diagonal EB. And the adjacent sides AE and ED are joined by EA. So how many diagonals do this pentagon has? Pentagon is 5-sided figure. Let's count. AD 1, DB 2, BE 3, EC 4, CA 5. So how many are there? More than 5 are there. Count properly. Let's count properly. 1, 2, 3, 4 and 5. So 5 diagonals are there for a pentagon because it has 5 sides and 5 vertices. So let's move to the exercise 4.2. This is based on the curves, open curves and closed curves. So in the first question, classify these following curves as open or closed. It is very clear. You can see these figures. See, this is open because this is not fully covered. There is gap between the sides. So this is an open. This is closed. See, there is no gap in the lines. So this is a closed. This is open because there is gap left here. So this is an open curve. This is closed. Got it, children? Question number 2. Draw rough diagrams to illustrate the following: open curve and closed curve. Just I have shown now. Like that, you have to draw open curve and closed curve. Open curve. So from a point you start drawing without using a scale or any ruler. So this is said to be an open curve. You can draw like this also. This is an open curve. So these are open curves. And closed curve. This also need not take the help of a scale or ruler. It forms a closed curve. So this is also a closed curve. Okay. Next question. Consider the given figure. No, question number 3. Draw any polygon and shade its interior. Draw any polygon and shade its interior. So you can draw a polygon by using a scale. So this is a polygon A, B, C, D and E. How many sided? 5-sided polygon. It's a pentagon. So question is, draw polygon and shade its interior. So this is said to be interior of the polygon A, B, C, D, E. This is boundary of the polygon. It is exterior. So let us shade the interior of the polygon. So like this you can shade the interior. So this shaded part is interior part of the polygon. Shade it well and write interior of the polygon. Question number 4. Consider the given figure and answer the question. This is the given figure. Is it a curve? Is it a curve? No, it's not a curve because it has straight lines. It is bounded by straight lines. See. But it is closed. Illustrate, if possible, each one of the following with a rough diagram. A closed curve that is not a polygon. That is not a polygon like this. This is a closed, but it's not a polygon. Let's try. Let's draw and see. An open curve made up entirely of line segments. An open curve. A polygon with 2 sides. Is it possible? A polygon with 2 sides? It's not said to be a polygon because it has only 2 sides. Okay, this is said to be a not polygon means it's an angle. This is said to be bounded by 2 sides. So use scale and draw this. See, a closed curve that's not a polygon. See, this is a closed curve but not a polygon. Okay. Question number B. An open curve made up of entirely of line segments. An open curve. See, this is a line, this is a curve, this is a curve, entirely made up of open. You can draw as many as possible curves, but it is said to be a not closed but entirely of made up of line segments. So this is a line segment, this is a line segment, this is a line segment, this is a line segment. So these are all line segments, but it is an open, see, it's an open curve. So this completes your 4.2.